All right, so with trig identities, what we're going to be utilizing is those trig Pythagorean identities, and we're going to go back and use those definitions that we have. So a couple definitions to know again. Remember that cosecant is 1 over the sine, and then again secant's 1 over the cosine. Again, if we can memorize tangent is sine over cosine and things like that. So that's what we're going to work on. And then this, do you see how there's that little box down on the bottom of the paper? You're not going to need all of that. So really, you can cross off the middle column and the last column because you don't need those. You really just need your Pythagorean. So when I'm talking about that, that's this. See this? You do not need this, and you do not need this. I think that's going to scare you more than help you. Okay? I'm going to leave that for pre-calc. Okay? So I'm going to make a little thing for your Pythagorean identities, and then you can use that on the test. So again, you don't need to memorize these. So I'm going to give you this little piece of that. So then you'll have that. Okay? So what we're going to be doing, you'd be like, okay, this is kind of goofy, is we're wanting to be able to verify trig identities, and that's what we're working on. So what we're going to do is use trig rules and identities to kind of simplify this. Okay? So when we're going to simplify, the first thing we're going to look for is like tangent. Does anybody know the definition of tangent? So that's where you have to kind of think. You're like, okay, what's the definition of tangent? What do you say? Sine over cosine. So I'm going to write this as sine of theta over cosine of theta. And cosine squared, I can't do anything with that right now. So I'm just going to leave it like that. And so notice I'm going to make this a fraction. So I'm going to put it over 1. And when I do that, we can cancel something. So what can we cancel? We can cancel 1 cosine. Because remember how we can cancel things diagonally, anything that makes a bow tie? So I can cancel a cosine and a cosine here, but there'll be 1 left. Is everybody okay with that? And then this is my answer. So tangent of theta, cosine squared of theta, simplifies to sine of theta, cosine of theta. And that's it. There's nothing else to do. Okay? So for number 5, we're kind of doing the same thing. We're reducing and then trying to turn it into something smaller or something better. So when I look at certain things, especially anything that's squared in the numerator, do we know what this is? This is 1. How do we know this is 1? Because this is a Pythagorean identity. So what's sine squared plus cosine squared? It's 1. So I'm going to replace this numerator with a 1. Everybody okay so far? So I used a Pythagorean identity to know that this is really equal to 1. Now, what's 1 over the sine? You should know that definition. That's cosecant. But it's not just cosecant, it's cosecant squared. And there it is. So I took this thing that was kind of ugly looking and made it simple. Cosecant squared of theta. It's not like a proof per se because it's not going to be, it's going to be more algebraic. So you're just using algebra things to simplify, to exchange things and make it work. It's more like a puzzle than a proof. At least that's how I feel about it. I feel like it's more of a puzzle for this particular part. All right. Now, for the next one, these are more simplifying, and then we'll actually get into what's called a verified trig identity. So in number 6, we have cosecant squared of theta minus cotangent squared of theta. Okay? It kind of looks almost like a Pythagorean identity, but not quite. So we either got to change one of these. So do you want to change the cosecant or do you want to change the cotangent? Don't change them both. Pick one or the other. So let's do cosecant. So now we look at our Pythagorean identities and say, okay, what does cosecant squared of theta equal to? Well, that's going to be equal to what? 1, not over, 1 plus, this is a trig identity. We're not using the definition of, so 1 plus cotangent squared of theta. So this was replaced, copy paste with this, and then we put this back where it was. So now the cool thing about it is, what's going on with my cotangents? Yeah, they get rid of each other. One's positive, one's negative, so they drop out. So therefore, this got simplified to make the number 1. I can keep the cotangent there because I don't have to, like, it's like substitution. I don't have to substitute everywhere. I just want to substitute where things make it easier for me. So for me, I want things to cancel out. I want things that are like terms. And so that's why when I said, let's not change both of them, let's just change one of them, there was a reason why I said that. Because if you're changing both of them, you won't have anything in common. How would you change the cotangent? Because this is your Pythagorean identity. So look at the bottom of your paper and say, okay, where on my Pythagorean identity is 1 plus, or pardon me, what is cosecant in my Pythagorean identities? Oh, it's 1 plus cotangent squared. That's where I got it from. It's a Pythagorean identity. Yes, please. Yes, I'm going to give that. It's not going to be on a sheet. It might be just on a little piece of paper, and that's what you'll get. Okay, next one. Mikhail. Yes. So for number 7, we're going to do the same thing. This one's more not necessarily Pythagorean identities. Why? Because it's not squared. You know, when things are squared, then you should start thinking Pythagorean identities. So cosine we're going to keep because cosine is cosine. Okay. What's that? That's just a different Greek letter, so don't worry about that.
So is it like instead of using X, you use
Kind of.
why? Yeah, why is there just a Greek letter in algebra?
Well, theta is a Greek letter and it's in algebra.
Yeah, but why? What does it mean?
What does that mean? This?
Yeah, or theta. What is theta?
That just represents an angle. Same thing here. This just represents an angle. You could. Oh, just calm down. Now, okay, so this is really 1. Okay, what do we know about cosecant? It's the opposite of sine. Okay, let's stay focused at hand. So, we change cosecant into 1 over sine. Okay, does anything cancel? The ones, but yeah. So then let's multiply across. So we're going to get cosine over sine. Do I know that? Yeah, we do. It's cotangent. So then that's my answer. So that's cotangent. Yes. Okay, the last one with simplifying. Notice it's squared. So we should be thinking Pythagorean identities. So what I would do is look at your numerator and say, do I know something that's going to be 1 plus the tangent squared of x? Yeah, what? Secant squared, yep. So when we look at the bottom of our sheet, if we look for 1 plus tangent squared of x, we see that it's equal to secant. So secant squared. Now let's look at the bottom. The bottom is equal to cosecant squared. Now you might think we're done. We're not. Because what really can we do to secant? So secant is really 1 over cosine. What is cosecant? 1 over the sine. And because this is a fraction, remember if we divide by a fraction, we're going to multiply by the inverse. Right, so we're going to get sine squared of x over cosine squared of x, which is not going to make just tangent, it's going to make tangent squared of x. X.
What sound does that letter
I don't know my Greek letters really well. I want to say that's alpha, but I'm not sure. I don't know. I'm not sure which that one is, to be honest. I'm bad with my Greek letters. I know this is theta. No, a delta's a triangle. I remember that one just because back in the day I was in a music kind of fraternity, organization, sorority, whatever you want to call it, and it was delta. So that's all I remember. Okay. All right, so that's kind of the pre-getting going. Now this is what we're really going to do with it. So we get to actually doing what we call a trig identity to verify. So, well, that was to get you used to the ideas of what we were doing. Now, gamma? Okay. So anyways, for this part, so verify means I want to get one side to equal the other side. Now you can't just write it. Some people are like, we're trying to do that last hour. They're like, oh, I can just write one side equals the other side. I'm done. No, you have to show, like with steps, with work, like what you're doing so you can get one side to equal the other side. And you can do it a couple of ways. You could make the left side, work with the left side, make it look like the right side, or backwards. Or you can even work a little bit on each side, so you want to get one side to equal the other and to be the same thing. So it depends what you want to do. So how about like in this case, let's clean up the right-hand side, okay? So I'm going to leave the tangent of theta, sine of theta alone. I have to turn this right side into the other one. So I'm just trying to prove that this statement is true using algebra and trig identities. So let's look at this numerator. Look at your identities. Find what is that equal to. Nope, 1 minus cosine squared of theta. Look at your Pythagorean identities. So it is equal to the sine squared. Because I found this right here. These match. In the place of this, I put what's equal to it, sine squared of theta. And then I'm going to keep the denominator, because there's not much I can do with cosine. All right, this side's going to stay the same. So let's break this apart. So this is really sine of theta times sine of theta over cosine of theta. Okay, so let's put these two together. So sine of theta over cosine of theta is tangent. And since I used this already, it's gone. So therefore, then I just have the sine. Do you see how one side equals the other? That's how you do it. Okay, but you have to show work of what you're changing things into. You can't just write tangent of theta, sine of theta equals tangent of theta, sine of theta. Because some people say, well, it's right. Yeah, but you have no evidence proving it and showing and demonstrating that. That's what verify means. You're supposed to be showing work. No. So they're always going to be true. So yes, I'm not going to give you any weird ones. That's a great question, though. Okay, let's look at the next one.
You're verifying.
You're verifying. Okay, so for number 10, we're trying to, again, verify. And so do we want to work with the left side or do we want to work with the right side? I probably would work with the left side. It's going to be a little bit easier. So plus you got parentheses. That just looks so much nicer to simplify. So this is where you got to think something really, really smart. What if I do tangent of x times cotangent of x? It's 1. They're inverses. OMG. Plus, now we're going to do tan of x times tan of x. So that'd be tangent squared of x. What do you mean, wait? But wait a minute. Oh, yeah, you're thinking right. Okay, so 1 plus tangent squared, you should be thinking, oh, Pythagorean and inverse, identity, da-da-da-da. So that's like right here. Woo. So therefore, secant squared of x equals secant squared of x, and we're done. No, it's secant squared of x equals secant squared of x. We're not going to divide both sides by secant squared of x to get 1 equals 1. You could. Don't need to. I got secant squared of x equals secant squared of x. We're good. Okay, so there's 10. Now, for the last one, this one is one where you might want to deal with both sides because it's a little bit harder if you don't do that approach. So what that means is, what if I manipulate both sides and then try to get it to work? So that's probably what I would do best with this one. So with cosecant, we got to think, what is cosecant? So what is cosecant? 1 over the sine. And then we need secant. 1 over the cosine. And so if I multiply that, this is going to be 1 sine of x cosine of x. There really isn't anything else I can do with this side right now. So now I'm going to go and look at the other side. No. So, but we're adding them. We're not multiplying them. If we were multiplying them, but then that wouldn't be true. If we were multiplying them, this would not be a true statement. So that wouldn't work. So we got to think, what is cotangent? So that's the cosine of x over the sine of x plus then the tangent, which is going to be the sine of x cosine of x. Now, how do I add fractions together? What do we remember from fractions? What do we need when we add fractions? A common denominator. And so for some reason, because there's trig identities, some people feel like they can't do that. And it's really easy. I mean, if that's dog and that's cat, you're going to have a common denominator of dog cat. So if I have sine and cosine, it's just going to be my common denominator. We're going to be sine cosine. Done. So I'm going to change this to sine of x cosine of x. Sine of x cosine of x. So if I put a cosine of x down here, what do I need to do to my numerator? I need to put another one here. Well, wait a minute. That means I'm going to have 2. So I'm going to have cosine squared. And then I'm going to put a sine down here, but then that means I need to put a sine up here. Otherwise, these are not going to be equivalent fractions. That's why we're doing this. Because if I want a common denominator and I want sine cosine, I'm putting an extra sign in the bottom, so I have to put an extra sign on the top. But there is already one sign on the top, so there's 2 of them. Okay, now, are we okay, or did I lose anybody on that step? Because that's common denominator stuff.
I'm not even on. I never got on, so you guys are like, you're already on the voyage. I'm back at land.
I think it's the other way around. You're adrift. So I'm going to put this together. I don't know how you guys don't remember stuff about common denominators, but okay. Well, I've been doing this for a long time, so you're going to have to get some practice in. That's all. You'll get it. It just takes time. It's fungus. It will grow on you. Okay. Now, we're almost done. So this is 1 sine of x cosine of x. Now, I added these together because since we have a common denominator, I can put these numerators together. Now look at your numerator. That's equal to 1. Because that's a Pythagorean identity. Sine squared of x cosine squared of x is 1. So I'm going to substitute in place of this numerator, gets a 1. And look at it. Got it. No, but it doesn't matter. I've got one side to equal the other side. If you wanted to, I mean, we could break it back apart and change both sides and do that, but that's, I got this side to equal that side. It's good. So we're good to go. Now, you're going to have a worksheet. The worksheet, the easier ones are in the front. So you're doing just the front. Okay, the back we're going to tackle tomorrow. Okay, so, and we're spending another day on this because there's no way you're going to get this in one day. because it takes time. Yes, go ahead, Josh. Pre-calc is they're doing this, and they're doing some more stuff with graphing that they're doing some of the same things that you guys did in Trig, and then they're taking it up to the next notch. Right, that's the same thing we're doing. Well, we're not doing all of that stuff, but yeah, they're doing quite a bit of the same